The V-2 rocket was the most advanced and revolutionary of Germany's secret weapons during World War II. Developed under the direction of Wernher von Braun, became the world's first operational long-range guided ballistic missile. Unlike aircraft or artillery, the V-2 did not rely on wings or propellers. It was powered by a liquid-fuel rocket engine that propelled it vertically into the upper atmosphere before it arced back down toward its target at supersonic speed. First launched in 1944, the V-2 was primarily used against cities such as London and Antwerp. It carried a warhead weighing approximately 1 ton. What made it particularly terrifying was its speed. Because it traveled faster than the speed of sound, there was no warning before impact. Civilians heard the explosion first. The rocket itself arrived silently and without interception. Technologically, the V-2 was far ahead of its time. It used gyroscopic guidance systems, advanced propulsion engineering, and aerodynamic stabilization. However, despite its sophistication, it did not change the course of the war. The weapon was expensive to produce and deployed too late to reverse Germany's declining position. Its legacy extended far beyond 1945. After the war, both the United States and the Soviet Union captured V-2 technology and scientists, incorporating that knowledge into early missile programs. In many ways, the V-2 marked the beginning of the space and ballistic missile age. Before the V-2 entered service, Germany deployed another revolutionary weapon, the V-1 flying bomb. Officially known as the Fieseler F-Wart 103, the V-1 was an early form of cruise missile, essentially a pilotless aircraft powered by a pulse jet engine. Unlike traditional bombs dropped from aircraft, the V-1 was launched from ground ramps or aircraft and guided toward its target using a simple internal navigation system. Introduced in 1944, the V-1 was primarily aimed at London as part of Germany's campaign of strategic retaliation. It carried an 850-kilogram high-explosive warhead and traveled at speeds of around 400 miles per hour. Its distinctive buzzing sound, caused by the pulse jet engine, became infamous. When the engine suddenly cut out, civilians knew the missile was descending toward impact. Unlike the V-2, the V-1 could be intercepted. Allied fighter pilots learned to shoot them down or even tip them off course with their wings. Anti-aircraft defenses also destroyed many before they reached their targets. Even so, thousands were launched, causing significant destruction and psychological fear. The V-1 represented a shift toward automated warfare. It was one of the earliest practical examples of an unmanned, self-guided strike weapon, a concept that would evolve into modern cruise missiles and drone technology. Though it failed to alter the strategic outcome of the war, the V-1 marked an important technological step toward the future of long-range precision strike systems. One of the most dramatic technological leaps of World War II came with the introduction of the Messerschmitt Me 262. It was the world's first operational jet-powered fighter aircraft, entering service in 1944. At a time when most combat aircraft still relied on piston engines and propellers, the Me 262 represented a completely new era of aviation. Powered by twin turbojet engines, the Me 262 was significantly faster than any Allied propeller-driven fighter. It could reach speeds of over 540 miles per hour, allowing it to outrun nearly every opponent it encountered. Armed with 4 powerful 30mm cannons, it was especially lethal against Allied bomber formations. A single burst from its guns could destroy a heavy bomber. Despite its advanced design, the Me 262 arrived too late and in too few numbers to change the course of the war. Germany faced severe fuel shortages, limited pilot training time, and constant Allied bombing of production facilities. Engine reliability was also a major issue, as early jet engines had short operational lifespans. Political interference further complicated its deployment. Adolf Hitler initially insisted that the aircraft be used as a fast bomber rather than purely as a fighter, delaying its effective introduction in its intended role. Even with these limitations, the Me 262 demonstrated the future of air combat. After the war, Allied nations carefully studied its design. It directly influenced the development of post-war jet fighters, marking the beginning of the true jet age in military aviation. As the war turned against Germany, the Nazi regime increasingly relied on technologically superior weapons to offset overwhelming Allied industrial strength. One of the most formidable examples of this strategy was the Tiger II, also known as the King Tiger. Introduced in 1944, it represented the peak of German heavy tank development. The Tiger II combined extremely thick sloped armor with the powerful 88mm KWK-43 cannon. Its frontal armor was so strong that most Allied tanks struggled to penetrate it at normal combat ranges. Meanwhile, its long-barreled gun could destroy enemy armor from distances where return fire was ineffective. On paper, it was one of the most powerful tanks of the war. However, this battlefield dominance came with serious drawbacks. The Tiger II was heavy, nearly 70 tons, which made it slow, mechanically unreliable, and difficult to transport. It consumed large amounts of fuel at a time when Germany faced severe shortages. Maintenance was complex, and breakdowns were common, especially during long movements. Production numbers were also limited. Only around 490 Tiger IIs were built, far too few to significantly influence the overall course of the war. Allied forces, meanwhile, produced tanks like the Sherman in far greater numbers, prioritizing reliability and mass production over extreme armor. The Tiger II symbolized Germany's late-war strategy, technological excellence combined with strategic impracticality. It was a powerful machine, but it reflected a broader problem. Advanced engineering could not compensate for limited resources and overwhelming Allied production capacity. Among Germany's most unconventional secret projects was the Horten HO-229, an experimental jet-powered flying wing developed in the final years of the war. Designed by the Horten brothers, the aircraft eliminated the traditional fuselage and tail layout, instead using a blended wing structure to reduce drag and improve aerodynamic efficiency. The HO-229 was powered by twin jet engines and designed to meet Hermann Göring's 3x1000 requirement, carry 1,000 kilograms of bombs, fly 1,000 kilometers, and reach speeds of 1,000 kilometers per hour. On paper, it was a revolutionary concept, combining jet propulsion with an aerodynamically advanced flying wing design. What made the aircraft particularly notable was its potential radar signature. Some modern analysts suggest that its shape and composite materials may have reduced radar reflection compared to conventional aircraft, leading to claims that it was an early precursor to stealth technology. However, while its design was advanced, it was not a true stealth aircraft in the modern sense. Only prototype versions were completed before Germany's surrender in 1945. The program never reached operational deployment. Allied forces captured surviving components, and the concept of the flying wing later influenced post-war aircraft development, particularly in the United States. The HO-229 reflected Germany's willingness to pursue radical innovation under wartime pressure. Though it arrived too late to impact the conflict, it demonstrated that aerodynamic thinking was already moving toward designs that would shape aviation decades later. One of the most advanced German secret weapons of World War II was the Type 21 submarine, often described as the first truly modern submarine. Unlike earlier U-boats, which were essentially surface ships that could submerge temporarily, the Type 21 was designed to operate primarily underwater. Introduced in 1944, it featured streamlined hull design, powerful electric motors, and greatly improved battery capacity. This allowed it to remain submerged far longer than previous submarines and travel at higher underwater speeds. In fact, faster underwater than many Allied ships could move on the surface. It also carried advanced sonar systems and could reload torpedo tubes rapidly, giving it the potential to launch devastating attacks against Allied shipping. On paper, the Type 21 had the capability to significantly disrupt the Battle of the Atlantic. However, it entered service too late. Production delays, technical issues, rushed assembly, and constant Allied bombing of shipyards limited the number of operational submarines. Only a few saw limited patrols before Germany surrendered in 1945. Despite its minimal wartime impact, the Type 21's influence was enormous. After the war, both the United States and the Soviet Union studied captured vessels carefully. Its design principles, particularly its emphasis on sustained submerged performance, became the foundation for post-war submarine development worldwide. The Type 21 demonstrated that Germany was not only experimenting with advanced rockets and jets, but also reshaping naval warfare. Though it failed to change the outcome of World War II, it helped define the future of submarine design for decades to come. As Germany searched for ways to strike Britain from continental Europe without risking aircraft, engineers developed another ambitious project known as the V3. Unlike the V1 and V2, which relied on propulsion after launch, the V3 was a massive long-range artillery system. It used a multi-chambered barrel design, where secondary explosive charges were triggered sequentially along the barrel to increase the projectile's velocity. The concept was to build enormous fixed gun installations capable of firing shells across the English Channel directly into London. Construction began at underground sites in occupied France, most notably near Mimoyec. If completed as planned, the V3 would have been able to bombard London continuously with high explosive shells from a distance exceeding 150 kilometers. However, the project faced serious technical and strategic obstacles. The gun required extensive underground infrastructure, making it vulnerable once Allied reconnaissance identified the site. In 1944, heavy bombing raids severely damaged the installation before it could become fully operational. A scaled-down version of the weapon was later used to fire shells toward Luxembourg during the Battle of the Bulge, but it had little strategic impact. The V3 reflected Germany's determination to develop long-range strike capabilities even as its military position deteriorated. It was innovative but impractical, expensive, and ultimately ineffective. Like many late-war wonder weapons, the V3 demonstrated advanced engineering ambition but failed to alter the course of the conflict. It remains a symbol of how technological experimentation could not compensate for overwhelming Allied superiority in resources and production. By the final years of World War II, Germany increasingly relied on the idea of Wunderwaffe, or wonder weapons, to inspire hope at home and fear abroad. The term referred not to one single weapon, but to a broad collection of advanced technologies: rockets, jet aircraft, advanced submarines, heavy tanks, and experimental systems that were presented as capable of reversing Germany's deteriorating military situation. The concept was heavily promoted by the Nazi leadership, particularly Adolf Hitler, and propaganda minister Joseph Goebbels. As Germany suffered defeats on both the eastern and western fronts, propaganda increasingly emphasized secret weapons that would supposedly deliver a decisive blow. Public announcements highlighted new rockets striking London, jet fighters outrunning Allied aircraft, and powerful new submarines entering service. Technologically, many of these weapons were genuinely advanced. The V2 rocket introduced ballistic missile warfare. The Me-262 ushered in the jet age. The Type 21 submarine anticipated modern underwater naval design. However, innovation alone could not compensate for overwhelming Allied industrial capacity, fuel shortages, pilot training deficiencies, and logistical collapse. Most of these weapons entered service too late, were produced in too few numbers, or suffered from reliability issues due to rushed development. Rather than shifting the balance of power, they often consumed scarce resources that might have been more effectively used elsewhere. In the end, the Wunderwaffe strategy reflected both remarkable scientific achievement and strategic desperation. Germany produced some of the most advanced weapons of the war, but technology without time, resources, and strategic stability could not prevent defeat.